Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Scripture, the Bhagavad Gita, Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Hey, everybody. Welcome to another live edition of the Hard Truths podcast, talking about Salvatore Pais's patents. Now, if you're new and you're not familiar with the patents of Salvatore Pais, these patents by U.S. Navy and U.S. Space Force engineer Salvatore Pais are called UFO patents. The reason they're called UFO patents, when you look at them and dig into them, is that these patents represent the capabilities of what has been seen in the UFO community by suspected UFOs that are out there. So the patents themselves are the secret to engineering space-time. And they implicate the U.S. Navy in having potentially known how to do this or know how to do this. So tonight, I want to talk about the patents. Before that, so there's basically 7 different things you need to know about Salvatore Pais, and I'm going to run through them right away. And then we're potentially going to have a guest on, and we're going to talk about Spacetime Metric Engineering. Number 1, the Superforce. What is the Superforce? The Superforce is this idea that there is this ether of energy that we can tap into that manifests all the forces that we experience, our entire reality. Our entire reality. That's how I would describe it. And that we can engineer that Superforce as c to the 4th, the speed of light, to the power of 4, divided by big G. That's the summation of the Superforce paper. I'm giving you the spoilers at the beginning, guys. Hope you enjoy it. The next thing is the Pais effect. Salvatore Pais and the Pais effect. The Pais effect is essentially breaking the Schwinger limit, achieving energy densities that are so electromagnetic energy densities that are so powerful that they can actually bend space-time in a significant way. And if we break through this Schwinger limit, we break through to the real nothingness. We create a singularity, a black hole. All of these terminologies just come together. So if you wonder, are you talking about black holes? Are you talking about, yes. Are you talking about wormholes? Yes. Are you talking about the nothingness of reality, of empty space? Yes. All of these things at once we're talking about. They're all really the same thing. Singularity, black hole, wormhole, whatever, right? We're talking about some crazy mind trippy shit, but it has been a solution to Einstein's general relativity equations that a wormhole should be able to exist. So, but you need to, when you create a singularity, you got to do the in math. In math, the singularities mean that, oh, all of a sudden things went to infinity, right? You got to do that. To do that thing that we go to infinity, that's the Pais effect. There you go. Okay. So just to recap the first two things, we've got the superforce. That's like the fundamental force of reality, which I think is Sal's nod to the ether. I want to get his opinion on it. And quick shout out to Salvatore Pais. We are working on a new date in the near future for a hard truths with Sal on directly. So I'll probably ask him if the Superforce is kind of his nod to the ether and 0-point energy without saying it. I don't know. We'll find out. So we will find that out soon. And then the Pais effect is essentially what we need to, the energy densities that we need to rip through reality. Now, these are important because when we had the last hard truths with Michael Perrone, who's a really awesome guy, and with Bob Grenier, talking about fusion, Michael kept saying, well, this isn't new physics. Yeah, exactly. It's actually not new physics. In fact, I can't really point to any new physics. Every bit of the physics that I've been talking about has all been publicly known, some of it up to 100 years or more, including the idea of the ether in Kaluza-Klein, which is 1926. That's 99 years ago. So the sad part is there really isn't any new physics involved. It's a matter of looking at the physics that already exists and going, wait, the physics that exists says we can make a wormhole. You're like, yeah, but we don't believe in that. We can't do that because it requires negative energy. We've just decided that that's not a thing we can do. That's literally the answer. Like, what? It's like physics and academia has a lot of these blind spots where they don't really realize it. Where you're like, wait, but your physics says we can make a wormhole. Your physics says that. Yeah, but we don't understand that physics, or it's magic. It's magic physics. Like, come on, man. So Sal's patents and the first two effects that I just described are essentially him saying, yes, look, the physics is right here. And it says that we can do this and manipulate reality just using straight up Einstein's equations and combining it with quantum mechanics, Schrodinger's equations. Okay. The next 5 things are Sal's patents. Okay. 5 patents. I'm actually going to break them up in an easier chunk to absorb for you all. And I also want to give some context. These patents were all released under the Trump administration. And now I've actually got Sal on the record saying he thinks these might have been like they slipped through the cracks. Like, why were these allowed? Like, there might actually have been more to actual disclosure on these patents getting out there. The first 2 patents, and by the way, only 3 of the 5 patents were approved. I don't remember which 2 were not approved. It doesn't matter. They're all real. The first 2 patents are related to energy. The first patent is the magnetically confined fusion reactor patent, which is essentially taking a cone or a cylinder, filling it with a noble gas, I believe is a noble gas, or any gas, I don't know, whatever the gas you want to use. And then having magnetic compression with counter-rotating vortices. Is this counter-rotating? I don't know. You get the point. Magnetic compression. And basically using gravity manipulating gravity to cause fusion to occur. Okay? Number one. The other patent that's energy related that he has is the high energy electromagnetic field generator. High energy electromagnetic field generator. So just rewind 1 second, going back to the Pais effect. If you were to go right now and talk to your physics professor and say, hey, this guy, I watched his stream, and this Pais effect guy is he's on TV saying that we can make a wormhole or whatever. And the physics professor is going to come back and say, we don't have the energy densities required to pull that off, and or we don't have access to negative energy, both of which would solve the problem. This patent, the high energy electromagnetic field generator patent, is Salvatore Pais basically saying we can achieve those energy densities. We can achieve those energy densities. It is possible. And from the context of Sal's interviews that he's done over the last few years, we've learned it's related to cold plasmas, non-equilibrium plasmas. And we also learned that is what Ken Shoulders was working on in exotic vacuum objects, or at least something very similar to that. So cold plasma. So now the first two patents, fusion reactor, and the second one is a way to produce high amounts of energy with plasma. Well, right off the bat, these two patents implicate that the Navy, U.S. Navy, has figured out fusion, cold fusion specifically, I would call it. Okay? But fusion nonetheless. Now, the last three patents, and then we're going to get to our guest who's waiting patiently in the back, and then we're going to start talking about these. The last three patents are inertial mass reduction for a transmedium craft. This is the one that people often reference because it looks like a triangle in the image. And in the triangle image, equilateral triangle image, people say it looks like the TR-3B. Maybe it is, maybe it's not sure. But the point of the triangle is that if you take that plasma and you fill a cavity around your craft, you can create a bubble and you can displace that craft on the inside from the outside entirely, which speaks to some of the claims, I think it was by David Grush, maybe by others, that the inside of these crafts can be different in the size than the outside. That's what that patent speaks to. Then there is the high room temperature or high temperature superconducting patent. Now, this patent speaks to the ability to induce superconductivity through vibration of the lattice, meaning taking the wire itself and vibrating it at certain frequencies. And then superconductivity can be induced at high temperatures, which would imply you might be able to induce superconductivity in any material. Any material. The idea of the superconductivity being important is that it's very important for energy amplification to have zero or low resistance, superconductivity. And if you can do that at high temperatures, potentially in a plasma, seems like that would be the key to figuring out how to take your plasma and fusion and start applying it practically to do magical things. And the last one, guys, is the high frequency gravitational wave generator. HFGW. My favorite because it just sounds dope as shit. I want like 3 high frequency gravitational wave generators. Wow. And then I'm going to combine them and I'm going to quantumly entangle them to another orb somewhere else. Frantically looks for his rubber band. I'm going to quantumly entangle these 3 orbs and then zap something away. The high frequency gravitational wave generator, we think we'll probably look into here in a minute as well, because it's just amazing to read. the implications of that are, of course, warp drives, but also speaks to energy amplification to a degree where you could destroy planets. That's in there specifically for a reason, and it's to scare you. So, okay, guys. So, tonight, guys, my guest is Daniel Davis. Now, Daniel Davis did an interview with Salvatore Pais, spoke about the math and the equations of warp drives, spoke intelligently with Sal, impressed me when I was listening. And so who better to talk about these patents, the feasibility, what's going on behind the scenes than Daniel himself. Dan, welcome to the podcast, brother. How are you doing?
I'm doing pretty good. Thanks for having me on. So I'd like to start with just saying my interview with Sal. The version that's on YouTube is actually a lot shorter than when we talked. We talked for about an hour and a half, but there was a few things he wanted me to trim out of there specifically. So there was more.
Okay.
So what do you want to get into?
Well, first thing I want to talk about is that Sal also today. Well, let me just say I correspond with Sal occasionally. I'd say we're friends, but we don't go hang out on the weekends or anything. He doesn't tell me his deepest, darkest secrets. But he asked me to post this letter that was a challenge to Elon Musk. So I think this is a good springboard to our conversation because Elon Musk is straight up CNN brain, primitive brain, Reddit brain, all of the derogatory comments that you could come up with when he's going on Joe Rogan saying like, no, nobody has gravity warp drive or anything like that. It's too impossible. No, if anybody had it, we would know. Basically just spitting in the face of the UFO community and anyone that thinks that electrogravitics are a thing. And Sal basically responded, wanted me to post it. And I did so gladly because I was also extremely triggered by that. And Sal's basically saying that the Superforce, the force of unification, he says, and he puts his paper, he says that quantum gravity is actually achievable, but nobody would accept his paper. And I think you can actually, speak to this quite intelligently. When I looked at the paper, it looks like c to the fourth divided by g, big G, is a big piece of it. So if you can give your interpretation of that in a second, and so he's basically asking that Musk should review this paper because Musk said on Joe Rogan that he doesn't see any alternative propulsion methods to advanced rocketry, but this paper with the Superforce refutes that assertion. And then he ends basically saying that it's the Superforce acting on the local spatio-temporal geometric structure, spacetime, which generates energy density and hence matter. Hence, see the Pais effect. It might be possible to manipulate and modify the inertia and resistance, modify the inertia, which is resistance to motion of an object or a craft locally by manipulating the Superforce. So then he just challenges them and then says something, I think in Latin that I don't understand, but it's probably dope. So what are your thoughts on off the bat? Do you think we can manipulate space-time?
Obviously, I think we can manipulate space-time. I think when it comes to Elon Musk, I don't want to speak bad about anybody, but I don't think we should ever attribute to malice what can easily be attributed to incompetence, right? Now, you have to think Elon's a very busy man, and he's doing whatever he thinks is going to be good for his business. He doesn't have time to keep up with the latest of warp drive research. If you look at some of his older interviews, when he's asked about if like warp drive's a thing, he says, how does he word it? Like, technically something like warp drive might be possible, but you need, the mass versus the mass of Jupiter with a negative mass in order to in order to make it happen, so it's impossible. And which is a pretty standard textbook answer in academia and among most physicists. And while that is technically right under certain assumptions, we need to consider.
No. Let's just go right into it. Why is that the noob way of thinking, and why is it that it's actually possible? I know you know the answer to this, so go ahead. You tell us.
So in order to understand why warp drives are, I'm not going to say a taboo area of physics, because they're a 100% a legit area of study in regular academic physics right now. I mean, so warp drive comes in full-fledged in 1994 with Dr. Miguel Alcubierre with his work, or with his paper, Warp Drive, Hyperfast Travel within General Relativity. Now, if somebody technically says that an Alcubierre style warp drive is impossible, okay, yeah, they're right. The math of Alcubierre does have, you need 10 times more than the amount of energy that's going to be in the universe. Okay, that's all fine and dandy. That being said, we need to recognize what Alcubierre did do is he introduced the idea of warp drive as a legitimate objective study within general relativity. It's another prediction of general relativity. Now, if we want to make an analogy of this, if you're familiar with the history of general relativity, let's back up to 1919 when Carl Schwarzschild came up with the first solution of general relativity, the Schwarzschild solution for a non-charged, non-rotating black hole. Okay, that's the first description within general relativity of anything, and it happens to be of a black hole, but we know they can't exist because why? All black holes, we found out, are going to have a charge and a rotation. This is where the Kerr solution comes in. Okay, so you had somebody who took the Schwarzschild metric for a black hole, and they said, okay, this is a good starting point. How can I make this more realistic? And so that's what Kerr did. So if we fast forward back to the warp drive study, people have done that for Alcubierre. People like Van den Broek by making it a multi-layer warp drive, which actually in his 1999 paper was the first thing to introduce the idea that the interior of a warp drive can actually be larger than the exterior. So it's not just Sale that talks about that. That's relatively well established within some physics papers. Dr. Hal Puthoff talks about that. I think Eric Davis talks about that a little bit too. I think Lakatsky talked about that. So there is a precedent for a lot of this stuff in actual physics when you start going into the deep and nitty-gritty of it. And we're at the point now in 2025, it's been 31 years later, we have 31 years of warp drive research. Only 2 of those papers have actually been written by Dr. Alcubierre himself. The other, I think it's pushing almost 400 papers now that have worked their way into the peer review. They've been done by other people, and you have all these weird, cool, complex geometries with multi-layer warp drives, people figuring out if you can use the Casimir effect, or if you just need to take a complex permittivity in order to mimic your negative well. And then you have other ones like Lentz and Heisenberg and Sean Fell, who are finding out that you can do a warp drive without
one step at a time. Let's take it one step at a time. So let's start with negative energy requirements. So there's 2 ways to look at it, right? Okay. We either need negative energy, which just cancels out the equations at that point. It doesn't matter how much you need because you have access to negative energy, right? Or we need a huge amount of energy that seems like an impossible amount. Those are 2 different approaches to it. Heck, I'd argue that Sal argues both might be possible.
So we
go ahead. What is negative energy?
So there's just, you hit on two big things here. You were talking about negative energy and then low power warp drive. They're not necessarily mutually exclusive, but they are 2 technically slightly different subjects. So we'll talk on the negative energy first, and then we'll get into some of the lower energy warp drive stuff that come from after that. This is this is the point that I was getting at, is that this is a very complex topic that's evolved into hundreds of different papers and people that have different views on it. And so how I was relating this back to your Elon Musk question is I can't blame him for not taking years of his time to go and actually read through all these hundreds of academic white papers when he's focused on making rockets. Okay, again, don't attribute to malice what can just be incompetency. You know, should he be reading these papers? 100%. You know that, I know that. Okay, that being said, the question is, how do we get that? Now, in order to, and I'm going to tie this back into your negative energy question.
Please.
There's a big taboo that you can't have negative energy, right? What does this come back to? Are you familiar with the 1957 Chapel Hill Conference?
Sounds really familiar. So yeah, once you give me the context, I'll probably remember. Go ahead.
Okay, so back in...
You gotta tell the audience anyway, so...
are you familiar much with like Eric Weinstein and Jesse Michaels? They talked about this a bit in Kurt Jungle. Okay, so the whole thing is that back during the golden age of general relativity, right? When you had all these different people, they were coming together post World War II, and they wanted to have this big conference to figure out what the future of general relativity was going to be for the future of physics. And so you had all these people that came together at this place, and it was sponsored by, funny enough, Wright-Patterson Airfield. Not many people talk about that. So Agnew Babson and Roger Babson, who established the Gravity Research Foundation, but then they were also working with Bryce and Cecile DeWitt and John Archibald Wheeler, who was very interested in the idea of anti-gravity at the time. Among the people that are there happen to be Thomas Townsend Brown. That's talked about in the book The Man Who Mastered Gravity, which is a biography on Townsend Brown. It's written by Paul Shopskin. Yep.
Yeah. That's next
anyway, so Brown is there. And again, Townsend Brown's whole idea was that if you have a charged negative plate
produce thrust.
Positive plate with a dielectric, so with an epsilon, and with a dielectric between them, you're going to get the negative hill chasing the positive hill, and then this is the prototype to your baby warp drive, right? Okay. So are you familiar with a man named Dr. Herman Bondi?
Bondi?
Yep.
Negative mass.
So Herman Bondi, he was a Yep, exactly. So he wrote this paper on negative mass.
I'm very familiar with him. I'm familiar with him. I'm familiar with Winterberg and the dirds that were written about negative mass, negative energy. So the reason why I'm asking about negative mass, just because I'll let you riff as long as you want, frankly. But I've decided I should just, instead of being coy, just tell you my opinion straight up, which is that I believe that there really is an ether. I think that science already agrees there's energy density in vacuum of space-time, which just depends on what you call it, zero-point energy, negative energy, or energy, whatever kind of energy you want to call it there. But essentially, negative energy, in my opinion, to your point on your charge analogy that you were eloquently pointing out, is going below equilibrium. We're in equilibrium all the time. We don't realize it because we're in it. But Sal Pais constantly talks about non-equilibrium thermodynamics, which is the idea that you can take something that naturally shouldn't break out of equilibrium, but you can break it out like a bubble, like take a bubble of energy out of nowhere and have it just coherently exist in our reality without going back to its origin. And that's what I think he's talking about with his Space Force paper. So to me, negative energy is not some exotic thing that the academics will tell you, something that doesn't exist, that's impossible. Almost everything in the equations is basically been proven to exist. It's usually a matter of our understanding and thinking about it. And in this case, I think if we change our perception of thinking about it to, oh, it's not this exotic substance, it's just energy. But it's negative because when you look at the math, it's just, if you look at a chart, it's below zero. Everything below zero, but doesn't mean there's nothing down here, right? There can be stuff above and below zero. So anyway, go ahead. Thank you for listening.
And so this is getting directly into why today the negative energy is supposed to be such a taboo thing. So Boney directly points out, probably semi-prompted by some of the insights provided by Townsend Brown, because remember, they were all at this Chapel Hill conference, that if you have a proverbial negative mass within the context of general relativity, because again, you can have negative masses and you can have positive masses in general relativity. The equation works both ways. It allows for it. Okay. It would allow things for like unbounded acceleration. And again, so this is baby prototypes to the warp drive. It would also allow for other things, like what at the time was called an Einstein-Rosen bridge, more known today as a wormhole. By the way, that term was coined by John Wheeler. So if you have negative mass, you would allow things for like wormholes, which they knew at the time would allow for things like faster than light communication, which now you have to start challenging the notion of causality. And that is something that you might not want to do. Now, we can go two ways with this on the decision tree.
Sorry, let me slow you down for just 1 second, because I want to say that John Archibald Wheeler as well, he also said, along with Richard Feynman, who won the Nobel Prize for quantum electrodynamics, that there's enough energy in the volume of this, whatever jar here of empty space, of the volume of empty space, to boil all the Earth's oceans, which he's essentially saying that if you look at the vacuum catastrophe, the answer is quantum theory is correct. There is a huge amount of energy, untapped energy, to be had. And John Archibald Wheeler was also the inventor of the first fusion bomb, I believe. So those guys at a conference is awesome. Now, tonight, I don't want to talk too much about the causality time travel side. I just want to talk about, can we make like warp drives and Sal's patents and stuff related to that.
So that was the exact point that I was getting at, though, is so that you can look at the decision tree two ways on this. They could have found one option that the physics was very easily weaponizable, because let's not even look at the time travel. Let's not even look at the time travel side. Let's just look when you have two masses and they can go off at unbounded acceleration. Well, if that can come to hypersonic speeds instantly, we can start making hypersonic weapons. If you have hypersonic weapons, you can get really high energies without even needing a nuke. And then, this starts to getting into some of the weapons applications of it. So that might be one reason that you want to put it into the dark and make it so that at least publicly, negative mass is a taboo thing. We don't want to talk about it because it can be easily weaponized. The other way that we could have talked about it is that now we have to start changing our theories, because we have to start accounting for all these weird wibbly wobbly time travel things, which you end up having to do anyways with a warp drive and the physics that come with any type of faster than light travel. Now, why is this somewhat semi-important to the negative mass thing? Well, you mentioned Feynman. All right, so going off Feynman, Wheeler, and all this, what did they say that could be a candidate for negative mass? Well, okay, it could be antimatter, because what an antimatter could just be, it's the counterpart but going back in time, and that's what it would look like it would have negative mass from certain frames of reference. So then this is where you would want to have matter-antimatter collisions to get these Schwinger effects, because remember, what are Schwinger effects? You're getting electron-positron pair production, electron-positrons being the antimatter, and then that causes a warping of spacetime. So it's very long-winded, but this does come full circle back to Pais. Now, I'm not sure if you caught in my interview where Sal says that he got some of these ideas after he left Northrop Grumman.
What about that?
Were you aware that some of Townsend Brown's intellectual property was sold to Northrop Grumman in the 1960s, mediated by the Rand Corporation?
No, really. The Rand Corporation mediated a deal for Townsend Brown work to go to the Northrop Grumman. Did they produce any did they produce the B2? Who produced the B2?
Northrop, yeah.
They did?
Pretty sure.
Wow. Yeah, because it is. It was produced by Northrop. Oh boy, that's sus.
Now,
So do you know where I'm getting at here?
Looking at Townsend Brown, what are the two things? Now, preemptively, I would like you to pull up the Superforce paper for yourself on page 3. So,
where did I put it?
When you have the negative and the positive charge plates, what are the two things that make the effect, the strength of the Townsend Brown effect? They're going to be the strength of the voltage at the charge plates is one thing, yes, but so you're going to be on page 3 up at the engineering the Superforce section. Now, the other thing that dictates the strength of a Townsend Brown type gravitator is going to be what the strength of the dielectric sandwiched between the conductive plates, i.e., you're going to have a change in the refractive index. You're going to be playing with epsilon and mu. So your strength of epsilon and mu in here is going to affect the strength of your charge plates. What is that doing? Okay, so looking back at our general relativity equation over here.
So can you just pause for just one sec? Because I just want to help out for the audience who doesn't know, when we're talking about mu and epsilon, we're talking about the permeability, magnetic permeability and electric permittivity of a substance. Space-time is considered to have one refractive index. But any material that they have different properties. Part of the idea of this as well is if you change the property of space-time, which involves changing the electric and magnetic permittivity and permeability, then you potentially can change the equations. Okay, jump back into it. Keep going.
All right, so you have your G mu nu, which is your space-time structure. So this is going to be your fabric of space-time that you can make your grid out, and then we can get into what the tensor relationship means on that if you want to. But digressing, this is going to be your coupling constant. Okay, and the reason that the constant is going to be the speed of light over here. Okay, now normally if this is constant for a given G mu nu. If you want to have, you need to have a lot of, so because this is very weak, because what is this? G over C to the 4th, that is the inverse Planck force, right? So it's not the Planck force, it's the inverse Planck force, so it's the opposite of the Superforce. So instead of being super strong, it's going to be super weak. So when this
Why
is
it the opposite?
Weak, you need to,
what's the significance of it being the inverse?
So because the Superforce or the Planck force, right, is going to be C to the 4th divided by G. So you see how one's the denominator and one's the other? So they're inverse of each other.
Yeah, okay.
So with this being very small, so it's going to be 10 to the negative 44 newtons instead of 10 to the 44, you need a lot of T mu nu. But what happens if you have a material that has a refractive index that isn't the same as the vacuum? All of a sudden, now if you make K very large, it's no longer a constant, it's now a variable. You can now get away with a very small amount of T mu nu mass energy. This is the low energy warp drive part of it.
Yep.
Now, where this is very good is while this, again, because of the Superforce paper, this is something that Sal directly talks about, so this is good for him. But who are some other people that have talked about this? Hal Puthoff has talked about something very similar to this. Travis Taylor has talked about something exactly like this. Dr. Jack Sarfati is talking about something very much like this. Dr. Chance Glenn has talked about something very much like this. Even Dr. Harold White has talked about something very much like this, about what happens if we can change the stiffness of space-time. What is the stiffness of space-time? It is the strength of this coupling constant. So it's not just one physicist that's barking up this tree. It's a bunch of them. They're just not quite talking to each other the way they should.
Why do you think all those people are saying that? I mean, to me, the answer is pretty obvious. And some of them has stated it explicitly, including Hal Puthoff's former partner, Ken Shoulders, who said, well, he learned in 1980 that the ether is real. There really is an ether. And then he started manipulating plasma because he realized once you realize space isn't actually empty, then now you've got a medium you can play with. So you should be able to make bubbles. And he was familiar with Thomas
we got to be
Johnson
very
Brown.
careful here.
Go ahead.
So one of the reasons that we have to be very careful here is that an ether would be a cosmological constant like substance. Key part there being a constant. This is not a constant. This is a variable. So now it's not a ether theory anymore. It's a quintessence theory, which is similar to ether. The only difference is the cosmological constant will be time varying. Now, the cool thing is about this is when you have this time varying thing, you end up getting a holography of time. And then at the boundary of this, one side is going to be a positron field. The other side is going to be an electron field. One's going forward in time. One's going back in time. That's the boundary. That's the Dirac sea where you're stealing the free energy from.
Okay, wait. So what's the name of my theory?
It's sort of like I just want to make sure I'm saying the right thing.
Quintessence theory. Is that the name of my theory? The one that you just said?
The old version of this would have been called, so an old version of this would have been called quintessence or quintessence. It's like the ether, but it's a variable instead of being constant. Better. So very, very similar ideas.
I love things that are just better, and quintessence is just better than ether. So you know what? We're gonna roll with it. I didn't really fully understand why the ether doesn't exist, because honestly, Winterberg had Planck ether hypothesis, which I also read. I kind of like it. Feels a little bit dated compared to where we're like at with quantum mechanic theory now. But yeah, the things you said about holographic theory.
Planck ether hypothesis. So one of the things about Planck ether hypothesis is that he makes a wrong. So Winterberg. I have a copy of it.
Oh, you're fine.
All right, you're referring to the
oh yeah, look at you
by Dr. Friedrich Winterberg. So
for the record,
he makes I think it's like paid.
Oh god.
So he makes a wrong prediction in that via his theory for the strength of the Higgs boson. So he gets his is probably right within a certain approximation, but he does get a couple things wrong. But like, it's good to take some influence from Winterberg because he does get a lot of things right. But like, take him with a slight grain of salt too, is all I want to say.
So let me just say this though too, and this isn't at you or really anyone in specifically, but I want to point out that I think part of the reason we haven't been able to get this disclosure of this technology has been because nobody can agree on the little things. So we can't all agree on the little things. So therefore we're throwing out the big thing, which is this idea that there's this energy all around us and we can tap into it and we can interact with it. It's like, who cares whose like little edge thing is correct or not? And because we can't all agree on one thing that explains everything, people are just saying, okay, we're just going to go back to our basic theory of general relativity. Like you get that feeling? Because you just listen to all those scientists, yourself, and you're like, oh, they're not talking to each other. Or do you have a different interpretation of that?
Yes. There is a reason that some of the theories are, if you look at it under a fine enough microscope, they are going to be slightly different. And there are going to be little details where like, well, if you're right and you're wrong, then the ship might go left instead of right, and we don't want to crash it. And so, there are going to be little squabbles among that. But the problem comes in is that once you have a little squabble, it becomes a big squabble, and then they don't want to work together.
And that's the thing. It's like you can't have these purity tests. Like, this is my big criticism of academia, is where it's like it's a fine line between, yes, we want to have this peer review versus people just start to become gatekeepers and nobody can really agree, but people kind of generally really do agree, but they just got this internal politics at play. And it's like, what's the answer to get through to that? I really don't know. But I just wanted to bring that up. I want to dig more into warp drives because you are cooking, my man, right here. And just to recap, the equations that you see over here on the right, basically we're saying if we can manipulate the thing that was previously a constant, which was the vacuum refractive index, the permeativity and permeability of spacetime. If you can make the refractive index negative, then you've produced Alcubierre's warp drive metric. You are the tool required for it. Yeah, C equals 1 divided by the square root of the permeability and permeativity times one another. So 2 ways. And here's the thing where there also, this is where there's 2 schools of thought. And you tell me just which one you're on. The Sarfadis of the world would say that you need a metamaterial to do it, because they're saying that, oh, well, space-time is empty. You can't manipulate the vacuum itself. You need a metamaterial. So you need a flying saucer or something like that, right? That has been engineered with the exact right chemical composition, almost like a microchip that's been built up at, big enough to house somebody. And then I think the other view of it, let's call it the Hal Puthoff view, and Eric W. Davis, is that you can manipulate the vacuum, and that if you polarize the vacuum, which is equivalent to just electrically charging it, like Thomas Townsend Brown effect, that you then change the refractive index.
That are happening in a given volume of space, which changes the refractive index. Yep.
Yeah. And then when you look at that from a charge perspective,
macroscopic.
And then once you look at it from a genuinely just charge perspective, you can easily polarize it positively or negatively. So then haven't you just solved your negative energy problem? Look at me cook.
So on one hand, you don't need, it turns out there's a lot of different ways you're going to be able to build a warp drive. There's going to be a lot of different ways to skin this cat. It's kind of like, on one hand, asking how do we, who's right? How do we build a warp drive? It's kind of like asking, like, who's right? What's the one way that we can use the concept of thermodynamic expansion of entropy to turn expanding heat into rotational energy to move something? Okay, well, we could do a steam engine. We could do a piston engine. We could do a jet engine. Like, there's a lot of different ways that still use the same core concept, but in terms of how they're engineered, is actually quite different. So I think we need to get away from the idea of that it's only Sarfati or it's only Puthoff or it's only. If you go and look into the nitty gritty, there's so many similarities between them. So if you look at Jack's paper, which is here in the volume 1 of the compendium. Let me grab volume 1, right? Yep. So it's his 2021 paper on lectures on Metric Engineering.
We should respect all of them, but Jack Sarfati is wrong. We don't need a metamaterial. We can manipulate space-time directly. I'm 100% confident.
He's right and he's wrong. There's a difference between saying that we don't need a metamaterial. We can use plasmas. Now, that being said,
yes,
we still can use a metamaterial. Why should we have to choose one or the other? This is the ultimate point that I'm getting at. You should be it seems like the best way to do this is going to be able to doing both. And if you actually look at the nitty-gritty of...
Once you've solved what you've got on the board, which is probably just the most important part, because once you've said, okay, we can change the speed of light, right? Like, look at what's on the board right now for my audience. If you're just listening on audio, it says big G equals 8 pi times big G divided by C to the power of 4 times this energy requirement we've got. Okay, so the energy requirement we've got is going to change based on that C to the power of 4. And when you look at C to the power, the C, that's the speed of light. Very big number.
No.
So C to the power of 4 is going to be a huge number. But C equals 1 divided by the square root of the permeativity and electric permeability times one another. So if you manipulate those what we think of as constants and they become variables, now you change your value for the speed of light in Einstein's equations. Now you've changed your energy requirements. I mean, that's beautiful. To your point,
and
it's just, I want to answer real quick. One thing is that why does it matter in terms of who's right or wrong? You're right, it doesn't at the end of the day. And yes, of course, with metamaterials, we can do basically just anything. It's an engineering challenge from that perspective. And it's a matter of like, how are we going to do it first? All right. The first way is probably going to be whatever's most natural, right? That we can do easiest, as opposed to like 3D printing a UFO from atomically from scratch. Anyway, go ahead.
Yeah, and there's going to be different levels of this. I would say that maybe like, do you know what the Ford quadricycle was?
Mm-mm.
So not like 1986, you had the Ford quadricycle. It was Ford's first like hand-built car before he even went production value on it, or before he even set up like the Ford Model T production lines. Anyways, where this analogy comes in is that Townsend Brown and his gravitators, I would say, is the Ford quadricycle of warp drive, and that there's going to be hundreds of iterations of slight improvements on the designs over the period of time of a civilization that's going to have this material. And so it would make sense that a lot of UFO events are going to be slightly different in categorization. It makes sense that they're not all the same, but there's going to be similarities between them. And to get back on some of the point on why we need to look past on some of the squabbling differences between some of these people, let's keep going with Sarfati and Putoff as a beautiful example of this. I have respect for both men. Jack, me and Jack get along more than Jack gets along with most people. I have a lot of respect for the guy. If you look and actually read like the nitty gritty of his papers instead of getting caught up that he calls everybody a schmuck, because let's be honest, that's what he does. He says right here in his 2022 paper, Lectures on UAP UFO Metric Engineering Physics, like right on page 2. Again, he's talking about the same thing right here. He has almost the exact same equations written, just with a slightly different notation, and he's talking about where use the effective derivative of electric permittivity, and there's several conceptual errors. And the conventional wisdom groupthink, it is argued that the vacuum speed of light is the same all over the universe in every direction. We now know from quantum field theory that this may not be true because of the actual values of vacuum permittivity, and permittivity are contingent on the dynamics of real photon scattering off virtual charge or particle zero-point fluctuation, ZPF, the dominant process for. And if you go and you read, it's almost word for word exactly the same thing as what Putoff's work is. Again,
no, he's definitely stealing Putoff's work, no question. I mean, I'm just calling Jack out. Jack, if you're out there, stop stealing people's work. It's pretty obvious that you're just like stealing off. You're like the kid, he's the kid in class looking at the kid next to him's work, right? Because Putoff already wrote all that in 1987. Before that, you can Tyler back. Putoff was asked. I don't know if you saw that episode that was that podcast episode by NASA that was just a few months ago. He gets asked when he learned about 0-point energy, and there's a hard edit all of a sudden, and you can tell, and they edit the answer out. So anyway, not to disrespect Jack, he's a smart guy.
So there was there's a recording you can find out there. So Jack had worked with Putoff back in the 70s. On a lot of this stuff, and so that's probably where they get some of the similar ideas came from, is because they were working on the same CIA program back in the day, and that's a detail that a lot of people either overlook or don't know about. So take that for what you will, regardless of who's right or wrong with this.
I mean, they're spooks, and
you have a lot of high.
Sorry, I was just going to say that
you have a lot of like high level people here that are either.
Oh, sorry. You go ahead. Oh, now we're drinking. Okay, we'll just.
Yeah, you have a high level. You'll have a lot of high level either government or academic people who are saying at some level that this is possible. They might be a little coy on the details, but I mean, that's kind of like how the nuclear program works too. I mean, like, we know that nuclear bombs are possible, but if you ask someone the nitty gritty on how you make fog bank, they're not going to tell you.
So, okay, let's actually refocus it back, because you mentioned your example of the quadricycle and people racing to get it done. Well, I have another story. It's called the Segway. I don't know if you're familiar with the Segway, but it was supposed to be this revolutionary scooter that everybody was going to get. But then it ended up costing like $5,000, being this big, huge meltdown. And now you sometimes see people driving them around for as a joke. But just because people have an idea doesn't necessarily they're going to make it. It's not going to be commercialized. And I think this is part of the problem too, because if people aren't working together towards a common public goal, then, you know, Jack's working with somebody on this over here. Hal's working with these people over there. You know, first of all, how does the public ever know anything's accomplished? We just don't, because all these people are just working on private endeavors. And second of all, like, if they're not working together, how can it be very efficient on something that would, you know, producing a warp drive like this, figuring out that on the board will change the world. And then if somebody did figure it out, maybe this is the most important question. Do they have a public duty to tell the world that they've figured out? If you have an experiment that you can show that proves of what all these people are saying, that you can manipulate the speed of light by manipulating refractive index of space-time or whatever, however they do it. Do you have a vested, does the public have a vested public interest to know that? What's your opinion? Do you have to tell people?
I could understand both camps. Now, that being said, it is also possible to understand something and disagree with it.
Yeah.
There's an interesting video on Rand's website for the Rand Corporation. Called if you go and you Google I think it's called like hypersonic weapon non-proliferation. You can take that context and you kind of apply it directly to this. I mean, like, why is it that no one's worried about North Korea's nukes? They have nukes. Everybody knows they have nukes. How come nobody's worried about it?
This guy.
We don't have a delivery system, right? So what happens if you have something that A, is a delivery system that can go anywhere in the world like that, and B, you don't even need to put a bomb on it anymore because it can be the bomb? You could make an argument that maybe we should classify some of this stuff. Now, that being said, you could have made the same argument that what if we had a bunch of satellites in the sky, and if you put a little chip in a little device, it could tell you exactly where you are on the planet. That could be used for targeting, that could be used for all kinds of weird things. Really good military applications, but maybe we shouldn't put it out there for everyone to use. But that's exactly what GPS is. And so, granted, the civilian version that we got wasn't quite as accurate as the military version, but eventually there was a trickle down. Now, our versions might not have been as good right off the bat, but if you go into today, the GPS on your phone, they can track you within a meter of anywhere where you are. Like that was military grade back in the 90s. So it's always a very interesting debate on, you know, should the military industrial complex get it? Should it go open source? I mean, like, because you can make so many arguments either way for it. And you can make arguments that there's really shitty figures in government that are going to use it for nefarious reasons, but then you can make that about everything. And it's a very good moral question. What do you think?
I think that we need to ask the question because, like you just said, I've asked a lot of people that question, and almost every single one reacts the same way you did, which is like, I don't know. What do you think? And I think you put it really eloquently, which is you can understand a viewpoint and not agree with it at the same time, right? Which is, I understand why they're keeping secret that they figured this out probably like 50 to 70 years ago. But at the same time, I don't agree with it, right? Like, yes, to your point, and you brought up the number one analogy that everyone out there should understand in terms of, if you want to really understand the why, if you're one of the people saying like, no, it's not that dangerous. Why is no one afraid of North Korea's nukes? It's not even the delivery system. We're not afraid of the delivery system. Their delivery system's too slow. We have something that can take their nuke and warp it back onto them. We have warp nukes. A warp nuke is unstoppable because, like as Dan just pointed out, that we don't even need the nuke anymore. It itself is a weapon. And then if we want, it's also a perfect defense mechanism. We can just do whatever we want. Right? So
are you familiar with a paper from Jessica Santiago's team called it's like stressor, pressor, and tractor beams within the confines of general relativity?
No, but I'm pretty familiar with those ideas. Yeah.
So those are legit things. You just like warp drive, we can manipulate the equations of general relativity, and we can get those effects. Now, it turns out if you build a warp drive within a certain way, it can also do these stressor beam and pressor beam and tractor beam effects. Now it turns into gravitational directed energy weapons, which can be good for some things and bad for other things. I mean, we could come up with really good medical uses and how this could be good for really precise medical surgeries. And I mean, there's a lot of good things that could come from it, or a lot of bad shit could come from it too. Now, why this
direct energy weapons are actually only used for good things. I'm pretty sure. Someone told me. I think it was George Bush told me that.
If you look at the intricacies of pretty much everything that Pais and Sarfati and all these guys working on warp drives are doing versus what Santiago is doing with the stressor beams, the warp drive stuff is working with near fields. Whereas the weaponization process, it's all gravitational wave stuff, but one's the near field effects, the weaponization is the far field effects. Now,
so stressors and pressors is just a fancy way of saying directed energy weapons, pretty much. Just so I'm catching on to that.
Or is that tractor beam will pull something to you. A pressor beam will. So a pressor beam will push something away from you, and then a stressor beam will either like squeeze or rip something apart.
Interesting. So, because we've strayed pretty far from the topic of Sal's patents, the stressor, or at least the pressor, however you want to look at it.
Have we though? Because we're on the weaponization.
No,
have we though? Because we're on the weaponization aspect of it.
You just revealed that was going to be the whole reveal. I was going to say that it seems like we've gone away, but not really, because the warp drive thing is at least one or two of his patents. But also now when we're talking about stressor and pressor, I was just watching a video on Friday on my live stream where, I think it could be argued that Tesla found out that under high voltages, high frequency, potentially some resonant frequency, the currents, the force flow will suddenly act scalar. Pressure-wise, will either press inward or outward. And if gravity is just a pressure force, then that is that stressor or pressor force. I think that's because it all just goes back to electric charge. What are your thoughts on that? Not to diverge too far, but I love the idea.
My specialties is more on warp drive instead of the weaponization aspects.
You don't want to make a doomsday weapon?
That would probably be a better question for like Santiago's. Do you know what a phased array is?
It's like a line in an array of like microchips or something. Go ahead.
Sort of. So normally when you have an antenna, right? So you have an antenna and then you broadcast waves in 360 degrees from it, right? Okay. Well, if you look at some of these radars that are in the front of jet aircraft, or let's look at a civilian application for the same technology. Let's look at a Starlink antenna, because a Starlink antenna is just a phased array antenna. You're going to look and you're going to have a little transceiver module that has a little tiny directional, little tiny antenna on here hooked up to your CPU module and your CPU and power module. Okay, and it's send out waves. Okay. What happens if you put another one next to it and you start doing the same thing? Okay, well, if you know anything about physics, you know you're going to start getting constructive and deconstructive interference through here. Okay, so some of these are going to cancel, and some are going to. So if you do enough of these, and you make a plurality of them, you can start to manipulate the beam here. And this is the whole point of the phased array system is now if you have enough of these and you put them together and you get really good in your computation, instead of transmitting in 360 degrees, you can do directional beam steering. So you can do a tight beam transmission, so to speak. Now, the thing is, if you look at Sal's papers, which I have over here, not his patents, his papers, the difference on them, actually, these are written quite better. One of the things that he talks about is that in his in the resonant cavity, right? So looking at his patent, he has the frontal view. That's going to be one. And so this is your resonant cavity happening in here. And then if we go to a side view, this is your resonant cavity where you're going to have the weird plasma action going on. What he talks about, we'll keep that up. In the patents, he talks about how there's a microwave emitter that you use to accelerate the frequency of the gas. Well, if you read the papers, which again, these are public, so I should be okay talking about this. He says to use a plurality of microwave emitters. What is a plurality of antennas? That's a phased array system. So you want to make the whole entire cavity lined with these phased array antennas. You can actually do this on the inside and the outside, so you can get your multi-layer warp drive. This gets into Vandenbroek methods, and then actually, if you want to get really clever in it, you can take a Salvatore metamaterial, and then you can sandwich it in between here, and that'll help reduce your effects even more. Again, there's ways that you can blend these techniques together. Anyways, what starts to happen here is when you're doing that around the whole craft, that's how you control how you steer it. But now that's the near field effects. Let's think about the far field effects, because we have the same thing here. All we have to do is just play with the strength of our phased array antenna here and play with how the beam forming is. And now all of a sudden, the same skin of the craft that we are using for propulsion becomes our directed energy gravitational weapon. So again, this plays back into the idea that, or the age-old idea that any propulsion system's effectiveness as a propulsion system is directly proportional to its use as a weapon system.
Wow, bro. Wow. Sorry. What do you do? What's your job? You said stuff about you have to be careful what you say. I don't know. Are you afraid of something? Sorry, go ahead.
No. I just respect for Sal on certain things that he asked me to not say publicly.
Oh, okay, got it. Oh, okay. I was just trying to make sure you're not, under some NDAs or something about what you're talking about. Because to be honest, my man, you are cooking. Wow, amazing. This is going pretty much like I expected, a little bit better, honestly. And I still have quite a few more questions. The near field versus far field stuff I'm going to have to look into. But I love that idea of it. And yeah, reality is it's a weapon, man. It's a weapon. It's a doomsday weapon, no question. Sal's high-frequency gravitational wave generator patent says in no uncertain words that you could amplify energy and use a plurality of these devices aligned around a planet and annihilate the whole planet, cause a space-time collapse in the vicinity of the
one
planet.
way you could do it, but there's more efficient ways that you could. I mean, if we really wanted to get our monkey brains going creative,
okay, we got Dr. Doom and Dr. Doom up here. Okay, let him go. I mean, there's more efficient ways. Okay. I'm just messing. Are you there?
Do you know what a relativistic kill weapon is? Did you ever read? Do you ever read Three Body Problem? Did you ever read the Three Body Problem?
Right now. Yeah, 3 Body Problem. Oh no, I haven't read it, and let's not spoil it because there's like a new season coming
Okay.
out. But I heard it's gonna be pretty dark. Oh man, that's I'm gonna enjoy it. Okay. And let's not get too dark on this. I guess let's change the topic a little bit.
Let's put our
Something out of
creativity
the
towards good things.
yeah, something better. Okay, so my chat wants, and you know what? It's not even my chat. It's me. I'm not gonna blame my chat. It's time to show you some videos. Okay. So the only reason why I'm even doing this, why am I even doing this? Why do I even live stream chat? I don't know. Is because these videos here. Go ahead.
The MH370 videos.
Yeah, I'm gonna break it out. You're the opinion what that they're fake or what? What's your opinion?
I am of the opinion that no piece of video evidence is ever going to be conclusive for the standards of academic proof. And I think that a way that we can reframe a lot of this research around warp drives isn't to call it UFO technology or UFO patents. I think that's a disservice to Sal. I think we can reframe it in a way that'll be much more palatable to physicists by calling warp drive what it is. And that's another prediction of our most successful theory being general relativity, much the same way that gravitational waves and black holes are a prediction of general relativity. I think once we can get the rest of the academic field to start adopting that mindset, we could have a technology demonstrator within 10 years. And that's just starting absolutely from scratch, what we know now in the public, assuming no black government program already has it somewhere in the back. Because no video is ever going to hold up to the idea of scientific proof. While something might hold in a courtroom, there's a difference between something holding in a courtroom to persuade a jury of peers versus something needs to reach 5 sigma with the data that is provided. And I like taking more of a scientific approach. I don't have the direct sensor data to look at that, to see what I just don't know enough to comment.
Yeah, no, you do. Here, let's dig into it. Let's not be shy. Look at what we're looking at right off the bat here. So right off the bat here, these dark lines in front of these orbs, like what are we dealing with here? Because this right here, there's been nothing like this ever in any videos. Like,
are you familiar with?
Go ahead.
North Sentinel Island.
Yeah, what is that? Oh man, I can't remember. Is that the one where they think there's like some ancient civilization or ancient technology or something?
Yeah. So at the end, so this is in the Andaman Islands in the Indian Ocean. You have this one island called North Sentinel Island. They have one of the few pretty much uncontacted tribes left. In
yeah.
And you have to wonder, are they themselves in a zoo hypothesis like scenario with the government of India being the zookeepers? When you start thinking about it objectively and analytically, it turns out the answer is yes. Okay. Yeah. If we're going to use now this zoo hypothesis scenario that we have as a case study right here on Earth in the Indian Ocean, right? We can extrapolate this out a little bit, I think, to the scenario that we might be in with some of these UAP. If you look at attempts to make contact with these North Sentinelese, anytime you go on the island, you die, basically, is what happens. They kill you. They appear to be very territorial, probably because in the 1800s you had this weird Englishman that came aboard that's a digression of the story. Anyways, they are not friendly to people who come on their island. Much like humans might not be friendly to people that come here. Now, there have been some positive interactions, though, between the islanders and the larger world. But it always happens on the water, because the islanders, they have canoes themselves. They have their own little tiny mini shitty spaceships that are nothing compared to our great big vessels, but they still have them. So every now and again, you'll get one of their fishermen will run into a more modernized fisherman out in the water, and they, might exchange some fish, or, they might give them a coconut, and there will be a friendly exchange instead of a hostile one. Well, what is the difference between this friendly exchange and this hostile exchange? It's where it's happening. It's not happening on the island anymore. It's happening in a more mutual territory. It's happening out in the sea, a place where it is hostile to both of this. So I'm not interested in trying to prove the validity of the MH370 videos, or the Tic Tac video, or the gimbal video, or, insert your whatever UFO pop culture video you want here. I am more interested in convincing physicists that this is a prediction of general relativity, so we can try to engineer our own ship to go, because obviously trying to contact them from the island's not working. So I would rather try to build a ship of my own, so I can go out there, intercept, pull aside next to them, open up a hailing frequency, and say, "Hey, nice to meet you on mutual ground. Who are you? Why are you here?" And I think that'll be a more productive way forward for humanity.
So I do too. And I totally agree with you. We're definitely in a zoo or a prison, or, something dark, which is probably also why they're not telling us it's not just the technology. It's probably also some deeper understanding about our place in this universe that a lot of people probably aren't ready for. But to your point about what your goals are. Now, I'm not asking you this because I'm going to then post this guy says the video is a real thing. Okay, that's not my objective in asking this. My objective in asking this is I already know this video is real. I already know this video is real. I already found the guy that leaked the video. I found more shit that you could possibly ever ask. Now, what I want is, if you look at it, based on what we just discussed about the warp drives, I already found that, no question, no doubt, this is based on Hal Puthoff's 0-point energy model and many other people. Like you know the names of the people better than I do, what have you. But they're manipulating negative energy in front of them. Why? Why do I know that? Because it's cold. It's just thermodynamics. They're either breaking the laws of thermodynamics, or they're manipulating 0-point energy in front of them. This video is being recorded because in thermal, partially because it's nighttime, but the other reason is because they want whoever's going to see this. Hal Puthoff might have seen this video, or Eric W. Davis, one of those guys. Why? Because the Navy is recording this shit. They're not just recording this. The reason why nobody will talk about this video, I'm going to tell you right now. The reason why people are blackballing me and what have you, it's not because I'm coming up with some wacky theory. It's because this video shows it's not aliens. Maybe there are aliens. Sure. I'm not saying that there aren't. I'm just saying in this case right here, whatever those orbs are, the United States government and Navy is controlling them. Because this whole thing is an operation. There's no way this whole operation was going down, and then alien orbs came down in the middle of it and did what they're about to do to this plane. Now, the last thing I want to point out is look at the heat signatures of the orbs. You were just talking about stressors and pressors. And boy, this shit was hard to figure out. I'm going to tell you, as an IT guy that knew nothing about this, it turns out this is a combination of like Ken Shoulders, exotic vacuum objects, plasma orbs, and also, like, now I realize why Sal wanted to talk to me. This is his fusion reaction patent basically here. And the heat signature is this, like, it looks like a Tesla sign. Turns out extremely distinct heat signature for fusion. Extremely distinct. But look at the temperature. That temperature, that orb, even the hot spark, the electrons, the yellow, the greenish part, that's still like almost lighter than the plane. So that's actually really cold. So this would speak to these things are manipulating potentially both forms of warp drive we were talking about, but at least the low energy warp drive version, because that thing's not white hot.
So so here's the thing though, if there's going to be negative energy, there's going to be a blue shift towards hotter radiation, towards warmer radiation, which would mean that the flash of the light that's dark there at the end should be warm if there's a blue shift instead of a red shift. Okay, so this is kind of getting into what I was saying of like, I have not spent the last 10 years of my life investigating UFO videos. I'm like, I had a UFO experience myself 11 years ago now, and people don't need to prove to me that UFOs are real. What's
no,
real
but
to me
here's the
is
point.
the
Let's dig into
research
what you
that
just
I've
said, the physics.
put together.
Because the story part's great. But here's the thing. What you just pointed out was really interesting because, yes, it seems like there might be both things happening. One thing I want to point out is at the same time, you have this. There's 3 frames. This plane is gone in 0.2 seconds. So if you imagine this as a destabilization of space-time, it's a hole that's being opened up for 0.2 seconds. And actually in the 4 frames, you can actually see it open and close as well. You can see that thing potentially just completely disappear. So it shows that if there is this negative energy, that it's a matter of ripping through the fabric of space-time. The other thing I want to point out too, when you look at this looks just when you look at it, the orientation of the orbs around the plane, does that not remind you of what like the ring formation in Miguel on like the warp drive, like theoretical warp drive views? They always have this like ring around an object. And then the last thing too is that what if the way they're manipulating space-time, well, one way is that they're just using plasma to do it. And the balls are plasma themselves here. But sorry, I the last thought, then I swear that I'll let you jump in and please address any and all of these points, is that you can see the endothermic event here, the black cold event. But in the actual satellite video that went along with it, which is some kind of false color infrared, not exactly sure, but it's like some advanced fusion of sensor data they have here. When you watch this version of it from a different angle, you can see an actual release of photons. You see that zap happen there? The reason we know this zap isn't just some cheesy effect is because it reflects off the clouds. So this would require somebody would have had to make a 3D model for this just to get the lighting right. So you can see it actually release photons. Now, I want to get your opinions on this because, first of all, man, I'm just going to be real with you. There's no fucking way there's no Banksy physicist out there making fake videos like this is going to know all this. Because as you're going to probably say here, I'm just going to, actually, you know what? I'm just going to be upfront about it. The release of photons speaks directly to the dynamic Casimir effect in terms of using, and the Casimir effect is how we might be able to produce negative energy. And what happens in that is they produce real photons. And this was experimentally shown back in like 2011 or something like that. And then the rest of it basically is Eric W. Davis and Hal Puthoff's Spacetime Metric Engineering and negative energy. And
it's not the Pais effect.
And the Pais effect.
It's not the Pais effect.
Oh, you don't think
so? The reason that it wouldn't be, and I will forgive Sal for overlooking this very specific detail, is that when you go into the math of his own theory on the controlled motion of electrically charged matter, so control rapid acceleration transients in order to get the Garden effect, when you get this coupling between spin 1 and spin 2, yes, you are going to produce photons when you're breaking the Schwinger limit, when you're making one of these artificial black holes. You're going to produce photons, 100%. Yeah. The thing is, you're only going to produce one very specific frequency of photon, specifically 511 keV photons, which fall into the gamma range, which you wouldn't pick up on optical sensors. Like, I don't know enough about the videos, so I don't want to comment directly one way or the other without having the same information that you've seen about them. So if you'd be willing to share some of the information with me for me to take a look at, I'd be more than happy to on some of my own time. But I don't like commenting about things in general. I haven't had a chance to put a lot of research into them, you know?
Yeah, sorry, I wasn't trying to ambush you on it. I just think it's relevant to the warp drive discussion. And yeah, and I want to know this stuff like you just mentioned, like the gamma drive thing, because there's either an explanation for it, or maybe they're just seeing it. Maybe it's some kind of hyperspectral camera, because they have that as well. Let me look back here at what else I wanted to point out about that. Oh, but there's something else that was related to the near field and far field. I mean, there's just too many similarities between just the science. You just independently described the science for the first hour, and then I show you these videos and the near field versus the far field effects. Well, what are the near field effects in that video? The near field effects are the orbs pulling themselves at subluminal speeds. But at the beginning of the video, the orbs are moving at roughly 2,000 to 3,000 miles per hour. So they have perfect speed control. But then we also see they have far field effects as well. They can converge. And why are they converging? It's actually very simple physics. It's Coulomb's equation, Coulomb's force. As the distance between the orbs gets smaller, the force increases exponentially. This is why it has to be the Schwinger limit. It has to be the Pais effect. That's exactly what Pais is saying, is that you increase the energy density. But yeah, but it could also just be, the other thing too is it looks like a low energy phase transition as well, because it's not like it's annihilating the scenery. You know, everything seems to stay in place for the most part. I mean, there's a little bit of movement, but it's not like all of a sudden the clouds are bursted away in a nuclear, explosion or something like that. And I guess I just bring this up because I think, to your point, people already have it. They've already got it. They've already got it figured out. I think they're hiding it for all the logical reasons you came up with, which are beautiful, by the way. You come up with all the right reasons for why they're hiding it. It's not as simple as evil, good, like that. It's like a matter of annihilation. And then the question is, so what do we do to get this out there? And I'm glad you brought up this idea of, you reminded me that you had this idea that we might be able to do this within like 10 years.
With enough funding.
We started right. With what? Go ahead.
With enough funding and enough resources,
yeah, with the
yes.
With the funding and the resources. I thought, you know what? What if we start like a public project? And what would our goal be? Because what we need to be able to do is basically teleport my Coke bottle from here to you right over here on the other side of the screen. Like, imagine if all of a sudden I move this and now the Coke bottle is in your room, but it actually is not a magic trick if we could actually do it. But if we could teleport something, it wouldn't have to be far. We just have to get it recorded. Teleport something from one spot to another. And if we could do that, that would be it. That would prove everything, right? It would prove warp drive.
You're better off doing a small scale warp drive that you can easily scale onto CubeSats and then scale up production from there.
The problem is they already do that with a bifield Brown effect.
Yeah, right? Exactly. So you're familiar with Charles and Drew down at Exodus? They have it's a continuation of the bifield Brown. Again, so bifield Brown effect is a baby warp drive. We can improve upon it from there. What we were saying earlier, and about how bifield Brown is related to Pais, is that they both say that the strength of your warp drive is going to depend on the epsilon and u, the strength of your dielectric sandwich between the plates there. Yeah. So we have ways that we already have baby warp drives working in the labs. Okay, perfect. Let's get funding for these guys so they can start putting them in CubeSats, so we can start having satellites in orbit that can adjust and reorbit without having to carry fuel. Okay, that's going to sell great. Use the funding for that to do the next generation of research. It has to be iterative on top of that. On top of that, go contact Greg Hodgson with the ZC Institute, where he's talking about doing the same thing, where you take the plasma fields and then you compress them using a warp. You make a warp field, and then that's how you can do fusion from here. And again, some will argue is that once you have this fusion, that's power that's mediated by general relativity, by general relativistic corrections, which was something that Winterberg worked on. that can be the, what's an analogy that I want? You don't just start the gasoline engine in your car, right? You have to use an electric motor to give it enough of a kick to turn over in order to fire up the regular engine. I think that fusion will essentially be the car starter for the 0 point energy, if that makes sense.
So I think the problem with all of that is it's already all been done. And like you're correctly pointing out that it's a process.
But it hasn't been scaled.
Like, go ahead.
It hasn't been, sure, it's been done, but it hasn't been scaled, it hasn't been made public, and it hasn't been put into the public domain, or hasn't been put out at a wide enough view yet. Some of it needs to be open source, some of it might be being suppressed. This comes into the question here, what is the best way of getting this technology out into the public domain in a way that the public will benefit from it? That is the $1 million question, isn't it? I think if I had the answer to that, I'd be a lot richer than I am.
Yeah, and so the problem there is that a lot of people have tried basically everything. I'm just going to go solo mode for just a second. So people have basically tried everything when it comes to bringing out this technology from a gravity perspective, from a free energy perspective. They've tried everything, and that you find that essentially a lot of people just fail. They spend their whole lives trying to bring it public, trying to invent something, never do anything. Then you have the people that are successful, and then they actually just sell out. So then it stays buried either way. And then you have the people that want to be noble, and those people end up getting silenced, blackmailed, or, you know, worst case scenario, they end up suiciding themselves tragically, bullets in the back of the head, fell off the balcony, clumsy. So I think it becomes, and then you have the people like even the new people who are like the Greers of the world, who've spoken to all the legit people, and they say, oh, well, we're going to make this laboratory, and this laboratory is going to be like film. It's going to be Big Brother. We're going to have recordings everywhere. Everything's going to be recorded. Nothing bad can happen. And you're like, that's just not feasible. It would be expensive. And like, the real question is, produce something for me that's undeniable. Because the Byfield-Brown effect, people do that. Even Falcon Space Labs did a recreation of it in a vacuum chamber, showed thrust. Charles Beeler did over 3,000 experiments. They've shown thrust. So it works in a vacuum. Does it get recognition? No recognition whatsoever. This is the part where I think people discount what I do as an influencer, which is, I say that tongue in cheek because I'm just an influencer, but the reality is you got to show me something that's actually impressive. And so I think what it would really take to convince people is not going to be, oh, I've lifted something off the ground. Cool. It's just ionic wind, bro. Right? They're going to debunk you like that. And it's going to be bullshit. You need to literally just, if we teleport something from one room to the next and find a way to do that at a low budget that can be easily done, I think that might be something that can break the camel's back. But I don't know. Ultimately, at the end of the day, if there was an easy way to do it, it would have already been done.
I think that's a good note for is if it's easy to do, then it would have already been done, at least on the teleportation side. I think I'll push back a little bit on the Byfield-Brown stuff, because with Charles Bueller and Drew and Mark, some of Mark's work at Falcon Space. I've been to Falcon Space, so I've been down to the lab. Nice people. There's a difference between. There's a lot of times there's a disconnect between when a technology is first recognized behind the scenes by people know that something's even impressive, and then there's going to be other people who say, well, oh, okay, cool, it moved. Okay, so what? Well, okay, well, because they don't understand the implications of how it's moving. And I don't think that necessarily the problem here is that people have bad technology. No, we found stuff like this that works, and now we just need to improve upon it. The issue is more people suck at marketing and people are corruptible.
Yeah. And that is a problem. It's us. The problem was always us. And the problem with the weaponization is us too. Us is the common denominator, which honestly, you're going to make me go down my villain arc. So I probably should back away a little bit from that. But let me ask you one other burning question before I forget about it. How much do you know about matter waves? And the reason why I bring this up is that Lockheed Martin has a coherent matter wave beam patent from 2013. And my understanding of matter waves would be this idea that you could actually get solid matter to act like a boson, to basically collapse down to a single point where it becomes a wave. So basically like rebuilding the double slit experiment, which also then again reminds me of teleportation, because that's basically
macroscopic quantum coherence, which plays back into cell.
What do you think about matter waves?
You have quantum programmable matter, which you can do that. So what does a Bose-Einstein condensate or some of these things? You're getting all the electrons or whatever matter is going to be in this whatever particular state that you're doing. It's described by a single wave function instead of individual. Now, this starts to get into like really esoteric of like, how are we going to interpret the wave function? And then, what does the reality mean based on what interpretation that we have? And it starts to get really, really complex from there.
Wait, so keep going about programmable matter. Tell me everything you know about programmable. So basically you're saying that Bose-Einstein condensate is basically like programmable matter because you're getting
not necessarily
basic substance to act like one solid wave function, like one solid thing. That's wild to me, because going back to those MH370 videos, I imagine
if you want to read about quantum programmable matter, there's going to be a DIRD that I think was written by Eric Davis for the OSAP program that you can find. That's pretty sure is literally titled quantum programmable matter, programmable quantum matter or something like that. But yeah, so if you go and you find out, it's one of the DIRDs that got released for the OSAP program, and you'll be able to learn more from that paper than I'll be able to tell you.
That's interesting.
So I can't tell you a lot about it personally, but I can point you into the direction of something where you can learn.
But you think that would be a method for potentially teleporting somebody, for teleporting solid objects? Like, is that
teleportation? Well, teleportation is now is teleportation instant? Okay, that's faster than light. What is faster than light travel? Faster than light travel is time travel. Now we have to start. So where is it going to? Now you start getting back reactions. Now there's other things that now you start getting paradoxes. How do we solve the paradoxes from here? Is it Novikov's conjecture? Is it many worlds? Is it a hybridization between the two? Probably a hybridization between the two. Again, this is why physics is like so hard for it. It's really hard to bridge the gap between like where PhDs talk and most other people, because there's a certain point where it's hard to talk about this stuff without equations, and then the moment you break out equations, most people's eyes just start glazing over, and view counts go down, and it's
so you don't need equations for time travel though, right? Like, I understand the equations for gravity, and because it's important, it's imperative to the discussion to describe that we're basically cheating the equations by reducing the refractive index of the medium. That's important. When you talk about time travel, you don't need the equations to know. It's like, oh, do I believe there are multiple worlds and I go to an alternate universe?
Yeah, you're talking about faster than light mechanisms.
Yeah.
Right?
And then, but sure, but even in that situation, it's like, is the time deterministic or not? Right? End of the day, we're still here. So, and if you're going to say that you might invent time travel at any point in the future, then at some point, if time was deterministic, someone's going to mess something up. And maybe we're stuck in that. Maybe that's the prison we're stuck in. I don't know. But for me, it's like the only way we're going to figure that out is if we test it and try it. So that's one of the areas where I tell people, a lot of people ask me, like, do you think they went to the future? Do you think it's like manifest in that video? And I tell people I don't know, because I don't have enough data. But what I will tell people is that those phones were still ringing. The families were claiming the phones were still ringing for 4 days. So I don't think they were in the plane.
So the reason that I keep bringing up time travel, the reason I keep bringing up time travel is that it's inherently tied to this topic. Unfortunately, as hard as it is to think about and all the mysteries and weird mind-bending paradoxes that we have to start thinking about it, because any system, this is just how the physics works via
well, let me ask you a smart question. I'll ask you a smart question on time travel. Let me ask you a smart one on time travel, okay, right? Because I just, this is a thought experiment, okay? I have a Stargate here on the surface of Earth, and the other side of the Stargate is on Mars, okay? And if I step through that Stargate, I instantaneously am on Mars. And if I step back through that Stargate, I'm once again instantaneously back on Earth. But each time I step through the Stargate, I'm always at a later point than I was when I previously had entered the other side. So I can go through the Stargate on Earth, go to Mars, go outside and wave at Earth, go back through the Stargate, show up in the Stargate. My girlfriend is still right next to me or whatever up in the Stargate, look up and see myself waving at myself. Now, does that break causality? Yeah. Go ahead. What are your thoughts on that? How does that work? Who says there's causality? That's faster
Who says
than
there's
light
causality
travel?
to break in the first place? Yes, that is faster than light travel.
Yeah. But is causality broken?
The universe doesn't have to make sense. Who says that the causality was a thing there to begin with? Again, so this ties directly back to what I started with earlier on the 1957 gravity research, the Chapel Hill conference there, and that one of the reasons that they suppressed the idea of negative energy is because it inevitably leads to systems that break our notion of causality. And that's more than most people want to think about. Now, you can go two ways from it there. You can take physics can start to branch from here. You can say, okay, we're going to accept that causality might be a human construct. It might be a false axiom to apply upon our theory of everything. Okay, what does the worldview look like then? Okay, that's one program we can do. The other thing that we can do is we can say, okay, we're humans. We know causality is a thing, so we can bake it into the axioms of our equations, and we'll see what's there. But then it starts to lead to some of these problems.
Causality, right? Like, you look at Einstein's equations, and what's the big thing about relativity? Is frames of reference. Is that in no matter what frame of reference, me and my own local frame of reference, I always experience time at a normal, quote unquote, rate. And this is the rub that how Pudov points out observer. That if I'm inside the warp bubble and I do a measurement, the speed of light will just be the standard constant speed of light. But if I'm on the outside of the bubble looking in, now it won't be anymore. So it's kind of like you're doing an optical illusion to the space-time in general. So
that's exactly what's happening in the warp bubble. Is locally you're not breaking the speed of light, but somebody looking at you from the outside, they're going to what look like something that is breaking the speed of light. Now, what's an Alcubierre drive that's passing superluminary going to look like? It's actually going to appear out of nowhere, and then it's going to split apart in two different directions. That's what it's going to look like to an outside observer. Really cool.
That's crazy. Actually. Yeah, but the thing is, causality is not being broken in that example. Even though I'm looking at myself on Mars, waving at myself, which should be impossible, there's no way for me to change anything in the past. I can't change what I'm waving at myself or anything like that, right? And I can't go back through the portal. I can't go through the portal and get there before I was waving. There's no scenario in which I can do that. And I can't get over this. I keep trying in my head.
Maybe not between that portal, but if you have another portal or say a mechanism that can open and close different portals at will, like that's actually what would a transition between sub to superluminal travel on a warp drive would probably be like. Now, let's say if you have a portal that you can steer around, that's essentially what a warp drive is. Now you can start doing all kinds of things where you can start playing and rotating your light cone to get it to overlap with past adjacent light cones, which normally would be out of your causal regions. You can start to make closed time-like curves. You can start to make things that are like closed time-like curves, but they don't connect back on each other, and this starts to turn into a form of time travel within the multiverse. This is why you have to have your navigational equations need to be so precise.
You convinced me. We need equations. You convinced me. You won that argument. Mark
now,
that
if
one
you're
up.
Okay, traveling multiverse.
No, that's a great conversation, and I'm curious.
There's a certain point where you need equations.
Yeah. So what is your? Just give me though. What is your? Since we didn't really ask, and I want to know. I mean, what's your opinion? And I'm not asking for a philosophical answer. Just give me, where do you lean in terms of, do aliens exist, and which are obviously the cutest of all of them? And then what do you think about the answer to the time travel thing? Do you think there's many worlds? Do you think it's deterministic, like the show Dark or whatever? Like, what are your opinions?
So time travel is definitely a thing. Again, so this gets into the whole, what the temporal continuum is about. Have you ever heard of Dr. Barack Shoshani? He's someone that you should look into. So he's a physics professor at Brock University. And starting in 2019, he started putting out a beautiful series of papers where he continues on the work of David Deutsch, who made the connection between time travel and many worlds, by the way. And he goes and Deutsch makes the philosophical argument very convincingly that faster than light systems, being time travel, only work in a many worlds type multiverse. Barack Shoshani, he takes that idea, the DCTC model, and he goes and he starts to expand on it very mathematically rigorously, because again, in the academic preface, you have three ways that you can treat time travel. You have Hawking's conjecture, the chronology protection conjecture, that just says time travel is impossible, that the universe will magically conspire to prevent it. Okay, well, that's boring. We're going to throw that one out the window. The next one is Novikov's self-consistency conjecture, meaning that you can go back in time, but that anything that you do back in time, you're predestined to do, and so it's one giant time loop. The other one is the many worlds option, where you have time goes branching and bifurcating, and this actually comes directly from the many worlds, and you're starting you're overlapping to kind of get these branches to touch so you can traverse between them. And that's really what a warp drive would be doing. There's actually reasons why a warp drive is really, it's a quantum entanglement machine. And then you can start tracing how these out, and these actually make a bunch of timelines, and then they come together to make the hot vibration, and then you can start mapping it out there, and then it gets into ways where you can feasibly come up with ways to navigate throughout the multiverse using these warp drives. And
so that's what you think?
Defy the laws of physics. Now, if you go to an earlier version of his Superforce paper, that he actually took this part out. I'm not sure why, but he believes it, and he talks about he is an Everettian, and in my interview with him, he talks about this new perspective on old physics can talk to a possibility of a multiverse concept. The CMB may be a window of one universe to another, thus allowing the perception of a multiverse.
Sorry, who was that?
Pais's word. That was Salvatore Pais.
Wow.
So again, it seems like it's not related at first, because you're like, oh, well, what does time travel in the multiverse have to do with Sal Pais and his patents and stuff? But when you actually go through the really long-winded version of it, it is in there.
Yeah, and that's the thing, is that it feels like Sal watered down what he wrote to appease academics, and he's actually just pretty much said this to me. Versus people that are more bold will just straight up say it, like he doesn't really touch on the time travel aspects at all. He never mentions UFOs or anything like that at all. Just specifically talks about engineering the quantum vacuum. Doesn't talk about the ether, doesn't mention 0-point energy, doesn't mention any of these concepts, but he does give nods to them throughout his work, because they're kind of required, I think, for this to make any sense.
Yeah, if you're good enough, you can pick up on them.
Yeah. So what do you think about aliens?
Part of the.
Do you think aliens are out there?
Well, again, so why the multiverse angle is relevant to that is once you understand the implications of how these craft work and the worldview that comes with it starts to become very hard to ask who are they, where are they coming from, when you start to realize they couldn't just actually this is what Jacques Vallée means when he says once you start to understand the implications of gravitational manipulation, the idea that they might just be an alien from another planet is actually the most mundane, boring possibility of all of the possible possibilities. They could be any species from any planet on any timeline on that planet. So it starts, when you start to do the math, really it comes out to about 10 to the 122 different possibilities, which is a huge number. And so again, this is why it starts to get back into my Andaman Island analogy of why it might be better for us to just build a craft and start asking some of these other craft, hey, where are you from? Instead of trying to speculate, because there's the tapestry of possibilities that they could be coming from is so vast. It could be from Zeta Reticuli, sure, or it could be the Soviet Union from another timeline. Like, we don't know. It could be. There's too many possibilities. So yeah, they're possible. They're out there somewhere. Are they here? Maybe. I wouldn't be surprised.
Yeah. Okay. What about your UFO experience? Did your sighting have anything that lingered with you in terms of the physics? Mark Scott asked from the chat.
I didn't know anything about the physics at the time. That's kind of what prompted me to start studying physics, because I saw something that I had previously deemed to be impossible. So I start digging into how is this possible, and then you like some answers more than others. You learn some groups are full of shit, others aren't full of shit, and eventually, when it comes down the rabbit hole, you start to realize the only thing that can't lie is math. And so that's why I like to try to promote the physics of a lot of these people more than I like to do, particular individuals or whatever. It's why I don't like talking bad about people. The physics are the important thing here, not my opinion.
What's your plan for trying to get it out there? Or you kind of said if you had unlimited funds, but what's your short-term plan? What are you trying to do? What are you working on?
I'm doing a talk on the history of many worlds for APEC next month. That'll be the next thing that I'm doing. Just
nice.
Do what I can when I have the time.
Well, yeah. Hey, man, Dan, I appreciate you coming on, man. I know we only planned on doing this for like an hour, but it's been like 2 hours. So I think we can probably cut it here. It's been a really good discussion on warp drives. I've learned quite a bit.
Here, so I probably should jump here.
Is there anything you want to shout out?
No, just again, I think one of the best things that we can do for ufology as a whole is to stop framing this as of how do we prove UFOs are real and prove whose sighting is the best sighting and which sighting is the most legit. Yes, we should monitor our skies. I'm not saying that we shouldn't do that. We should keep track and monitor our skies. But we need, because there's a stigma behind UFOs, whether we like it or not. So this is why we need to start framing it, at least for the academics, about how warp drives are a prediction of general relativity. We need to figure out how the UFOs work. It gets the same end result. It just, one path might receive a little bit more resistance than another.
No, I totally agree, Dan. And it's funny because now for the 4 Orbsies crew out there, we're going to have to start saying, general relativity, you were right again. Look at you, general relativity. We can make warp drives. We can teleport stuff. Einstein, never wrong. But no, in all seriousness, I'm planning on talking to Sal again in the very near future. Do you have any follow-up questions or questions that you would like clarity or more things from that you think the public should know about in the conversation?
No, just look into many worlds and there's something there.
Really? Okay. I'm going to ask him about that. Well, Dan, thank you very much for your time, sir. I will let you get back to it, and let's be in touch. Have a good one, brother.
All right. Thank you so much, sir. Have a good night.
Okay, guys, that was our review, which ended up just turning into more of a scientific review of warp drives and the physics behind warp drives, although still extremely connected to Sal Pais's patents. I personally liked the part most about the far field and the near field. I'm definitely going to be looking more into that. And of course, what he said at the end about the many worlds. I think I will talk to Sal about his interpretation of time and whether or not he believes the many worlds hypothesis or if time is potentially deterministic. So that was fun talking to somebody who's clearly an expert on the not just physics, but the topic of the history of quantum gravity or gravity manipulation, whatever you want to talk about, whatever you want to consider it. And then lastly, I want to go through all these donations that we had real quick. Arthur, thank you very much. I appreciate you, man. Normal IT people out here just working hard. Mark Scott, thank you for the huge donations. Tic Tac Tundra, I saw your donations, brother. I appreciate what you're doing as well. Levy, thank you very much for your donations. Appreciate them. And Trizzle, stealing one of my avatar names. Ashton, talk about reverse rotation of the orbs. Is there reverse rotation of the orbs? I'm not sure, but that might be something to inquire about in a future time. And Tic Tac, thank you for all the donations. Appreciate you. I don't know about Commonwealth Fusion. Oh, I do know a little bit about Commonwealth Fusion. We will dig more into the fusion aspect later. Thank you. Paul, thank you very much, Paul, for the donation. Paul Gleason, so nice of you. And then the last two donations from Levy again, which is everything is the difference between potentials. Even CPUs work this way. Voltage is a scalar potential. Clock speed is a temporal scalar. But yet the non-physical voltage switches physical transistors at the clock frequency. Point being, one point is a scalar, no direction. At another, now you have a distance. Time emerges from space, which emerges from two scalar points. It's a beautiful thought, is that there is no time without what we call distance. It's true. So is everything really an illusion? I'd argue that in a sense it is. It's both an illusion, but also real at the same time. And then one last donation by David R. How can Elon not know about any of this? So I think that Dan put it very well. Dan said, Elon's not out there reading the scientific papers. Elon's out there banging Twitter thoughts like Ashley St. Clair and whatever other hoes he's sleeping with, all his baby mamas. He's got 14 children. You think he's got time to be reading Hal Puthoff's scientific papers? No, he pays people to read the scientific papers. He doesn't do any of that shit himself. The other big reason is that even though people can be wide awake on media manipulation, medical manipulation as well, we'll just call it that to be indirect, they can still be extremely blue-pilled and eyes wide shut when it comes to things like science. Because physics and science is hard. So what do most people do? Most people simply go to their trusted resident expert, which is usually some PhD that is a professor at some university. And they ask that person, hey, what's real? And that person tells them their expert opinion. Well, it turns out like 80% or more of those academics are completely wrong. That's why Elon Musk doesn't know. I've spoken to, who was it that I spoke to? I spoke to a congressman Congressman I like, actually. Still like. And they told me that when they asked a PhD, they basically asked a PhD, did what I described. They basically asked their local PhD expert, probably one of their friends too. And they're like, no, it's all that 0-point energy stuff's bullshit. You can't really do all that, blah, blah, blah. I'm like, are you kidding me, bro? Are you kidding me? We are just in a bad way. So that's why Elon doesn't know. A combination of reasons. Now, could be wrong, and it could be that Elon does know, and he's just Oscar-worthy actor, and just pretends like he doesn't know, and just pretends like he doesn't know how security clearances work. Elon Musk doesn't know how security clearances work, chat. He tried to pretend like he had a security clearance, so he's going to know if they've got anti-gravity technology. Can you guys imagine how ridiculed I would have gotten if I came out and I was like, guys, hey, I have a security clearance. And by the way, because I have a security clearance, it means I know things. And therefore I know the MH370 videos are real because I have a security clearance. And then people would come out and be like, dude, just because you have a security clearance doesn't mean you automatically know shit. I'd be like, no, the security clearance was just credibility. That's what I ended up saying. So, okay, guys. I think that's going to be the end of the stream tonight. Thank you guys very much for all the donations. Thank you. Special thanks to Dan for that amazing conversation. Make sure you guys check out his APAC conversation. A lot of those APAC conversations, I'm not going to lie, they're pretty dull. But when you have smart people like Dan, some of the people that I've interviewed on these streams, now you have the context to understand what they're talking about when they speak in their nerd language about their warp drive stuff. Now we're like, oh, you're basically just manipulating this region of space-time using electricity? Okay, that's a lot simpler than all your sigmas and your mu naughts and your epsilons, right? Okay, guys. Have a great night, guys. I appreciate it. All of you guys' follows, subscribes, and sharing of all the content. Let's talk more on Wednesday, guys. Peace out. Have a good one.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead. through the cosmic paths that we now tread. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our